Hello and welcome back to class. This is Applied Anatomy and Physiology, AAP 301 for the College of Natural Health Sciences, Bermuda. My name is Dr. Delcina Bean Burrows, and this is lecture number 21, where in today's lecture we will be discussing the cranial nerves. Our lecture objectives for 21 are: at the end of today's lecture, students will be familiar with the 12 cranial nerves and their functions and be able to create a unique mnemonic to remember the order and names of the 12 cranial nerves. We begin today's lecture by discussing the cranial nerves. The cranial nerves connect the muscles and organs of the head and body directly to the brain. So guess what? You've got nerves. There's a lot going on in and on our heads at any given time. Our eyes gather information about light. Our ears collect sound waves, and our nose detects odorants in the air. Our tongue tastes our food, and a vast array of muscles stand ready to help us communicate with others using speech or facial expressions. What keeps these busy muscles and organs doing their thing? Well, in large part, the cranial nerves. There are 12 pairs of cranial nerves, and each has a unique function and sensory and/or motor designation. Fortunately, anatomists have numbered the cranial nerves for everyone's convenience. Like the spinal nerves, the cranial nerves are part of the peripheral nervous system. However, their connection with the central nervous system is largely through the brainstem, which is the midbrain, the pons, and the medulla oblongata, instead of the spinal cord. So let's take a look at the first cranial nerve, or CN1, which is the olfactory nerve. The olfactory nerve is a sensory nerve running from the nasal epithelium to several different structures in the brain. Specialized neurons that hang out in the nasal epithelium detect molecules called odorants in the air and transmit information about them up to the olfactory bulbs, which sit on top of the ethmoid bone. Structures called olfactory glomeruli in the olfactory bulbs transfer the sensory information to the olfactory tracts, which then carry it to several different areas of the brain, including the amygdala, the hippocampus, the septal nuclei, and the primary olfactory area of the temporal lobe. Now to discuss cranial nerve number 2, which is the optic nerve. If you are reading this slide, you can thank your optic nerves. When light enters the eye, it is detected by special cells in the retina called photoreceptors. The information these cells collect is transmitted back to the brain by way of the optic nerve. You might already know that the right visual cortex, the part of the occipital lobe where visual processing begins, receives information mostly from the left eye, and the left visual cortex receives information mostly from the right eye. The optic chiasm, the first brain structure reached by the optic nerves, is where this crossover happens. Some fibers from each optic nerve cross each other, while others continue on to deliver their message ipsilaterally. After the optic fibers reach the lateral geniculate nuclei in the thalamus, each hemisphere has a lateral geniculate nucleus. The signal passes to the primary visual cortex in each hemisphere. Now let's take a look at cranial nerve number 3, the oculomotor nerve. The oculomotor nerve controls the intrinsic and many of the extrinsic muscles of the eye. It extends from the midbrain through the superior orbital fissure of the sphenoid to the orbit and splits into two branches. The superior branch innervates the superior rectus and levator palpebrae superioris, which is the upper eyelid, muscles. The inferior branch innervates the medial rectus, the inferior rectus, and the inferior oblique extrinsic eye muscles. Here's a bonus fact. The oculomotor nerve serves the parasympathetic nervous system functions of constricting the pupil to regulate the amount of light entering the eye and adapting for short-range vision by contracting the ciliary muscle, one of the intrinsic eye muscles. We now move on to cranial nerve number 4, the trochlear nerve. Like the oculomotor nerve, the trochlear nerve travels from the midbrain through the superior orbital fissure of the sphenoid to each orbit. It innervates the superior oblique muscle of the eye, which controls the eyeball's up and down movement. Interestingly, although the trochlear nerve has the smallest number of axons of any cranial nerve, it has the longest intracranial course. Now let's discuss cranial nerve number 5, the trigeminal nerve. The trigeminal nerve is a big one. It originates in the pons and has 3 branches: the ophthalmic branch, the maxillary branch, and the mandibular branch. It's also a mixed sensory and motor nerve, which means it has fibers that deliver sensory information to the brain and fibers that carry commands for muscle contractions. The sensory fibers receive information from mucous membranes, sinuses, and the skin, while the motor fibers control the muscles of mastication and the pharyngeal arch. Did you know that the sensory signals from the trigeminal nerve and not the olfactory nerve prompt sneezing? Let's take a look at cranial nerve number 6, the abducens nerve. The fibers of the abducens nerve originate in the aptly named abducens nucleus in the pons. This nerve always makes me think of giving people the side eye because it innervates the lateral rectus muscle, which is responsible for the lateral rotation, which is abduction, of the eyeball. Now let's discuss cranial nerve number 7, the facial nerve. The facial nerve has quite a few branches, meaning 5 main ones: the temporal, the zygomatic, the buccal, the mandibular, and the cervical. It also has a posterior auricular branch, which innervates a portion of the occipital frontalis muscle. Like the trigeminal nerve, it contains both sensory and motor fibers. The sensory fibers receive input from taste buds on the anterior portion of the tongue and proprioceptors, the receptors sensitive to position and movement of the face and the scalp. The motor fibers innervate muscles in the face, scalp, and neck, as well as the stapedius muscle in the ear. They also innervate mucous glands in addition to the lacrimal and salivary glands. Now let's take a look at cranial nerve number 8, the vestibulocochlear nerve. The vestibulocochlear nerve may not have as vast a network of branches as the facial nerve or trigeminal nerve, but its 2 branches serve 2 very important functions. The vestibular branch transmits information back to the brain from the vestibule and the semicircular canals in the inner ear to help regulate equilibrium. The brain areas that receive this information are the vestibular nuclei in the pons and the medulla oblongata. The cochlear branch receives information about sound that has been gathered and translated into electrical impulses in the cochlea, the seashell-looking structure of the inner ear. Have you ever heard of the ABR, which is the auditory brainstem response, hearing test, and wondered what the brainstem has to do with hearing? Although there are cortical areas dedicated to sound processing, the cochlear nerve's destination is the cochlear nucleus of the medulla oblongata, which means that the first information about sound that reaches the brain comes through the brain stem. This is cool, isn't it? We will now take a look at the cranial nerve number 9, the glossopharyngeal nerve. The glossopharyngeal nerve is a mixed sensory and motor nerve important to swallowing. Its motor fibers innervate the stylopharyngeus muscle, which elevates the pharynx and larynx, and the parotid salivary glands. It receives sensory signals from the proprioceptors of the swallowing muscles, baroreceptors, which are the pressure sensors, in the carotid sinus, and the chemoreceptors in the carotid body. Also, since the glossopharyngeal nerve innervates the oropharynx, it is the initial recipient of the information that triggers the vagus nerve to produce the gag reflex. We now move on to cranial nerve number 10, which is the vagus nerve. The vagus nerve is a well-traveled and crazy busy polymath. You might think that innervating the muscles of the pharynx, larynx, and soft palate and receiving sensory input from the external ear, taste buds in the pharynx and epiglottis, and proprioceptors in the throat and neck is enough. But wait, the vagus nerve just keeps on going. It has branches in the thorax and abdomen that are key to the parasympathetic nervous system's regulation of heart rate, sweating, breathing, and even the movements of the smooth muscles of the gut. And of course, have you ever heard of the vasovagal response or vasovagal syncope? Well, the vagus nerve is in charge of vasodilation, which is dilation of the blood vessels, which causes blood pressure to drop. In combination with the reduction of heart rate, this low blood pressure reduces the amount of blood that can get to the brain, resulting in fainting. Now let's take a look at cranial nerve number 11, the accessory nerve. Do you enjoy moving your head? Well, if you nodded yes to that question, you just experienced your accessory nerve in action. The accessory nerve innervates the sternocleidomastoid in the neck, which is a primary mover in neck flexion, and the trapezius in the shoulder, a primary mover in neck extension. And we have the final cranial nerve number 12, the hypoglossal nerve. Last but not least, we have the hypoglossal nerve, which, true to its name, travels under, because hypo means under, the tongue, which means glossus. The hypoglossal nerve controls the intrinsic and extrinsic muscles of the tongue, with the exception of the palatoglossus, which is innervated by the vagus nerve. So it's incredibly important for speech and swallowing. And here we have our cranial nerve table, which illustrates the type of cranial nerve as well as whether or not it has more than one branch. In terms of the first cranial nerve, the olfactory, it is purely sensory. The second cranial nerve, the optic, is also pure sensory. Cranial nerve number 3, the oculomotor nerve, is purely motor, and it has superior and inferior branches. Cranial nerve number 4, the trochlear nerve, is also purely motor. Cranial nerve number 5, the trigeminal nerve, is both sensory and motor, and its branches are the ophthalmic, maxillary, and mandibular. Cranial nerve number 6, the abducens nerve, is motor. Cranial nerve number 7, the facial nerve, It is both sensory and motor, and its branches are the temporal, zygomatic, buccal, mandibular, cervical, and posterior auricular. Cranial nerve number 8, the vestibulocochlear nerve. It is purely sensory, and its branches are the vestibular and the cochlear. Cranial nerve number 9, the glossopharyngeal nerve, is also both sensory and motor. The vagus nerve, cranial nerve number 10, is both sensory and motor. It has numerous branches throughout the head, neck, thorax, and abdomen. Cranial nerve number 11, the accessory nerve, is purely motor. And cranial nerve number 12, the hypoglossal nerve, is purely motor. Now, here are some mnemonics in terms of trying to remember the cranial nerves. You might find it helpful, you may not, but if you want some handy mnemonics to remember the names of the cranial nerves and which branch nerves are sensory, motor, or both, then you can use, for example, for the names of the nerves, you can use this one from Saladin's textbook. It's called Oh, Once One Takes the Anatomy Final, Very Good Vacation Ahead. And it's up to you as to whether or not you want to use that one. And then for sensory versus motor, you can try some say marry, money, but my brother says big brains matter more. So the beginning of each word would indicate whether or not the first, second, third, and fourth all the way through is either a sensory, a motor, or both. So you might find it helpful, you may not. Okay, so we have reached the end of today's lecture, and for assignment number 21, you're going to list the 12 cranial nerves and describe their functions. And you're going to create your own cranial nerve mnemonic, whether it is trying to remember it according to the order, or if you want to remember it as whether it's sensory, motor, or both. It's completely up to you, so I look forward to seeing what you will come up with. And of course, this assignment is due this coming Sunday by 11:55 p.m. If you have any difficulty with this assignment, please send me an email or a text message. My office hours are always the same, Thursdays from 4 to 6 p.m. And with that, I look forward to receiving your assignment, and I will see you in the next lecture.